I'm going to introduce the moderator for this panel. We're very thrilled to have Delegate David Bulova with us to moderate the panel, and we appreciate him coming and doing this for us. He is going to introduce all the members of the panel, and Delegate Bulova, I think most of us know him because he's the perfect man for the job. Between his membership on the General Assembly committees on this topic and his involvement in general with Bay TMDL activities and his private business, his consulting. So he's the perfect man to moderate this panel, and we appreciate very much him coming. Thank you. Delegate Bulova.
Thank you. All right, good afternoon, everybody. All right, excellent. I'm not going to say that I'm the only thing standing between you and oysters and beer. What I'm going to say is that your reward for being such great participants today is oysters and beer at the Muscarel. So anyways, what a great tee up and what a fantastic group of presenters that we've had all throughout the day. But the last two presenters really did a very nice job of setting up some of the policy issues that we're talking about. I was very excited to be asked to moderate this panel in particular. Most of you probably don't know that before my current job and being in the legislature, I worked for the Northern Virginia Regional Commission. And one of the favorite job titles I've ever had was the Coastal Zone Program Manager for Northern Virginia. One of the wonderful parts about that job was on a quarterly basis, we had meetings of the coastal PDCs where I got to go out to the eastern shore and to the northern neck and down to Virginia Beach and Middle Peninsula. And of course, when it was my time to have everybody up to Northern Virginia, they didn't seem quite as excited to be coming up there as I always was going down to those other places. But they're beautiful, beautiful parts of Virginia. And again, that was a great time for me professionally. So it's great to see so many people here from that part of my life. Over the past couple of years, the General Assembly and certainly the administration has really been struggling with the issue of what to do about sustainability of groundwater in eastern Virginia. There's certainly a recognition, I think, as you heard from our legislators earlier in the day, that what we do today or what we don't do today is going to have just enormous consequences for the Commonwealth of Virginia. And so when we think about the economics of it, we think about sea level rise, we think about potable water sources, we think about the impacts of our ecology. All of those things are contingent on the decisions that we're going to be making now. And I guess what's even more powerful is that you talk about how slow groundwater can move. Well, policy can move just as slow as groundwater. And it's a double-edged sword. And so, for the things that we do move forward on today, it's going to take a while to go ahead and implement. And at the same time, if we make mistakes, especially when you're dealing with groundwater, it can take years to go ahead and reverse the effects of those as well. And so we have a responsibility to make sure that we get it right. The General Assembly has been working and planning to do exactly that. We last year went ahead and charged our Joint Legislative Audit and Review Committee to look at water supply statewide. They actually did a report out of their initial recommendations at the Water Commission meeting that we had earlier this week. And of course, we have the Eastern Virginia Groundwater Advisory Committee that's been meeting. I do remember the first time that I heard about what Hampton Roads Sanitation District was proposing, and it was at a Water Commission meeting probably about 2 years ago. And I thought, wow, this is awesome. It's got to be too good to be true. And it just kept going. And so fast forward 2 years later, again, to that Water Commission meeting that I was at earlier this week, and we're still talking about it. And legislators and regulators, I think they're frankly excited about the prospects of being able to make something like this move forward. But it really does, though, hone in on the importance of asking those very, very fundamental questions. And so that is, if we do move forward with this project, how do we ensure that public health and the environment are protected? And what issues do we need to raise now in order to ensure that our decision makers have the very, very best information and tools to make decisions that are going to affect generations to come. And so I'm very pleased to have with us today a distinguished panel of individuals who are going to help to tease out those questions and issues, and I'm looking forward to hearing from them, and at the end, hearing your great questions for them. So really briefly, I wanted to introduce our panelists. Our first panelist is Mike Markus. Mike actually has real-world experience in injection technology. This isn't very theoretical to him at all. As the manager of the Orange County Water District. He's been with the district for 28 years and has been responsible for managing the implementation of a $480 million groundwater replenishment system program and the oversight of a $142 million groundwater replenishment system initial expansion project. So not as big as a budget as what we're talking about, but pretty substantial. Mike obtained a BS in Civil Engineering from Caltech and a Master's of Science in Civil Engineering from the University of Southern California. We then have Jeff Mosher. He is the Chief Research and Strategic Planning Officer at the Water, Environment, and Reuse Foundation. And then prior to that, he served as the Executive Director for the National Water Research Institute. Jeff provides scientific and technical support on a variety of relatively easy, solvable problems, such as human risk assessments, chemical and microbial occurrence in water, the fate and transport of contaminants in the environment, and water treatment technology performance evaluations. He received his BS in chemistry from a very nice little college that's close by called the College of William and Mary, and an MS in environmental engineering from George Washington University, which also is my wife's alma mater. Peggy Sanner is with she's the Virginia Assistant Director and Senior Attorney for the Chesapeake Bay Foundation. In that position, she provides legal and policy guidance on all aspects of environmental law with a particular focus on the Chesapeake Bay. I have been subject to, I've witnessed her advocacy talents firsthand on numerous occasions in room 402 of the General Assembly building. Peggy is very active in the Virginia Bar. She received her law degree from Rutgers and holds graduate and undergraduate degrees from the University of Pennsylvania and Swarthmore College. Russ Baxter, who I've known for a long time, has the distinction of serving not one, but two governors as the Virginia Deputy Secretary of Natural Resources. During the latter, under Mark Warner's administration, he was primarily responsible for working out Virginia's commitments under the 2000 Chesapeake Bay Agreement, and he's also served in policy positions at DEQ, the Chesapeake Bay Commission, the Virginia Conservation Network, and the Chesapeake Bay Foundation. He received his master's degree in environmental planning from the University of Virginia and a bachelor's degree in government from Oberlin College. And last, but certainly not least, we have Rich Batiuk. Rich is the Associate Director for Science Analysis and Implementation at EPA's Chesapeake Bay Program. He's been with the EPA and the Bay Program for 32 years and has led the program's effort to integrate science into policy decision-making process, something that's much easier said than done. He received his BS in environmental science from the University of New Hampshire and his MS in environmental toxicology from American University. And so I hope that you will agree that we have a wonderful panel up here and we're looking forward to their presentations. And so what I'd like to do first is invite Mike to come up. He is going to kick us off by providing some perspective about his project out in Orange County, how it is similar to and different than what we are proposing here in Virginia, and some really good lessons learned for us to take into account. So thank you very much, Mike.
Well, thank you, and I am that phantom guy from California that's been referenced a couple times today. I learned something very new this morning at breakfast. I ordered ham and eggs, and they said, "What kind of ham would you like?" And I said, "Isn't there only one kind of ham?" And he said, "Well, we have Virginia ham also." I said, "I'll try the Virginia ham." And the server said, "Well, it is a bit salty." And I said, "Oh, that's okay." And it was delicious, by the way, but I've been drinking water all day. As was described, I am the general manager of the Orange County Water District. Now, the Orange County Water District, we're groundwater managers in central and northern Orange County. We're talking about Orange County, California, not Orange County, Florida, Orange County, Virginia, Orange County, wherever. But we do serve 75% of the drinking water supply to about 2.4 million people. And that's groundwater. That's water that's pumped out of the ground directly into the water distribution system. So it's very important for us to find sources of water into the groundwater basin, sources of supply. And we can't rely on Mother Nature. We get about 13 inches of rainfall per year. The last couple of years we've received 5 and 8 inches. So we are in a drought, and we're coming into this year. Last year was supposed to be a big El Nino. It kind of fizzled. It happened in the north part of the state, not in the southern part of the state. So we have to find a reliable source of water. For us, that's why we've turned to recycled water. This is a cross-section of our groundwater basin. So off to the left, in the dark blue, that's the Pacific Ocean. And the aquifers are connected. So our aquifers in our groundwater basin, the shallow ones, are connected to the ocean. And back in the 1970s, the mid-1970s, we had to build a series of injection wells and a wastewater treatment plant that we call Water Factory 21, because we were using at that time 21st century technology. But the old water factory actually was the first plant in the world to use reverse osmosis to treat wastewater to distilled water quality. A lot of people don't know that. We operated that for over 40 years. So we've been injecting highly purified water into our groundwater basin for the past 40 years. I'll talk about another project called the Groundwater Replenishment System, much larger project, which has since replaced the old water factory. Now, the thing about our aquifer, we mentioned, I think Ted was talking about the confined aquifer. And part of our aquifer is confined. However, on the right-hand side, it's unconfined. And what this means is the sands and gravels come up to the surface. So all you have to do is dig a hole, put water in it, and it percolates down into the basin and refills it. So we do a lot of our recharge up in that area. We do injection along the coast, and we have plans for the final expansion of our groundwater replenishment system to build some injection wells that would inject water into the middle part of the aquifer. Little cartoon that kind of shows the whole thing, how we inject. So those are the individual aquifers. They are separated by clay layers. However, when we inject, we target specific aquifers. And so we inject into those aquifers, and it helps push or keep seawater back. This is a huge concern for us. In the mid-'70s, we saw the seawater coming inland, and of course, if it contaminated the groundwater basin, we'd have to have wellhead treatment on any well to pump water out because of the high salinity, the high TDS. But by having that barrier there, we're able to have injection wells just a couple miles away, and it has no impact as long as we can keep the seawater back. So the groundwater replenishment system, what is it? It's a 100 million gallon per day advanced water purification facility. So we take secondary effluent from the Orange County Sanitation District, which is the wastewater authority. Remember, we're groundwater managers. They do the wastewater side. We take the secondary effluent, we run it through an advanced purification system, and then we turn it into drinking water, and then we put that back. It becomes a source of supply for our groundwater basin. So we see wastewater not as a waste, but as a resource. And we've been operational. We went online January of 2008 with our first building of the facility, 70 million gallons. And it didn't take our board long. We turned around about a year later and decided to build the initial expansion, which was another 30 million gallon increment. So we're up to 100 million gallons per day. And we are the largest planned indirect potable reuse project in the world. So I'm not going to go through, I'll just go through these real quick. We use a 3-step process. Starts with microfiltration. Microfiltration, removing any bacteria, protozoa, suspended solids out of the water. We then use reverse osmosis. And this is really the workhorse of the treatment process. Now, you hear Charles talk about you're studying different technologies. The reason we're using reverse osmosis is the salts that are coming in the wastewater are very high, 1,000 parts per million. So we have to remove salts to be able to put it back into the groundwater basin. It doesn't sound like you have that issue up here. You have lower TDS coming in. So we use a reverse osmosis. The added benefit, of course, is it removes any viruses, organic compounds, and dissolved minerals in the water. So this really does remove everything. However, it does not remove some low-weight molecular organics. And that's why we have the third process, which is the UV light with hydrogen peroxide. And with this process, we're taking just about everything out of the water, producing near distilled water. As far as regulatory oversight, We have groundwater regulations that are currently in place. So the State Water Resources Control Board, under them there's the Division of Drinking Water, and they are the ones that set the criteria for us. So we know what type of treatment, we know what we have to test to, and it's all lined out as far as treatment, TOC, which is total organic carbon limit, travel time, blending, no federal role in regulating reuse. The one thing that we did do, because at the time we were designing the project, those regulations hadn't been adopted. And so we felt a very important key was to hire, or to put together an independent advisory panel. And this panel helped the regulators decide what would be included in our permits so that we could move forward and build a project before the regulations were in place. This really was a key. We did it through the National Water Research Institute. We had leading experts on all sorts of different disciplines on the panel, and this was one of the keys to success in the project. As far as reliability, there again, we have to test for over 400 compounds, and we test and we remove those, just about all of them, to non-detect levels. So if you take a look at the list, there's 28 volatile organics, all non-detect. You can just go right down the line. 16 endocrine disrupting chemicals and pharmaceuticals, all non-detect also. And we've been able to replicate these over the past almost coming up to 9 years now. As far as the benefits, we're creating a new water supply. We heard talk, I think Ted mentioned about the question came up, well, can we dump it in the bay? And why would we do that? It's a resource. We need to use it again. And that's what we're doing. For us, it increases our water supply reliability. In Southern California, most of the water comes from two places. Either it comes from the Colorado River 200 miles away, or it comes from Northern California, which is 400 miles away. Those are the two main sources of supply into Southern California. So if there's cutbacks in either of those systems, we would suffer cutbacks as well. Recycled water gives us a reliability component. Also, from an energy perspective, it takes half the energy that it would take to pump water from Northern California to Southern California, because it has to go over a very large mountain range, and about 1/3 of the energy that it would take to desalinate seawater. So we can produce this water cost-wise for half the cost that it costs for imported water, and about 1/3 of the cost of desalinated water. So it just makes sense. What have we learned from about GWRS? And in case you don't know, that's a picture of our Governor Jerry Brown in the middle, the second one on the right. The public can accept it if the need is clear. Obviously, we had the need. We need the water. The outreach is effective and ongoing. Elected officials and community leaders make the commitment. Quality is higher than the alternatives. Regulators have that oversight, ongoing oversight. And we like to say the more people that know about GWRS, the more they accept it. And my PR people made me put this slide in. I don't like to toot my own horn, but we have been the recipient of several international awards. The piece of crystal on the right is the Stockholm Industry Award. Below it to the left is the Lee Kuan Yew Prize given to us by Singapore PUB. We have been on, I won't say highlighted, but we have had a clip on 60 Minutes, BuzzFeed, 40 plus awards, all sorts of recognition. And for those that are in the audience that have any doubt as far as the technology or that it won't work, I'm here to say that I think we have proven that it does work and it will work. And that's a picture of our site. If you're ever down in Southern California in Orange County, that's my contact information. Give me a call and we'd love to give you a tour of the facility. With that, thank you very much for having me here today.
So thank you. Excellent presentation and nice overview. Couple quick questions. And so earlier on in the audience, there was some discussion about public perceptions. I'm from Fairfax County. I'm a product of drinking water that has been cycled from the Upper Occoquan Sewage Authority through the reservoir and then down to the Fairfax County Water Authority. And I guess the ironic part is it'd actually be cheaper if you just hooked the two up. It actually gets dirtier once you put it into the reservoir and you got to clean it back up again. But so how have you dealt with public perception in Orange County, both at your initial inception and are there still residual concerns that are out there?
Sure. We actually started, and that's a great question, because our board had the vision to understand that we could have a perception issue. There had been a couple projects in Southern California, one in San Diego, one in the San Gabriel Valley, and that's where the phrase toilet tap was first coined. And so our board, one of the first things they did in 1995 when we were originally starting out on the project, and that's the other thing, these projects take time. I mean, we started our pilot testing in our back in 1995, and as you saw on the slides, we went online in 2008. But the first thing that they said is we need to develop an outreach program. And so they went out and they hired a firm, and we did some polling and focus groups, developed some messaging, and then we went out and we communicated to our stakeholders. The first group we went to were the 19 cities that were going to receive the water. So we went to them and got letters of support from their councils. We went to our local elected officials, explained to them, the elected officials at the federal level as well, all letters of support. Health and medical community, environmental community, all huge supporters of the project. So we kind of built up this coalition, if you will, of support. And then we went out and we spread the word. We gave over 120 presentations in over a 10-year period. We took people that were on the team, engineers like myself that aren't used to public speaking, and put us up in front of the public and had us explain exactly what we were going to do. We felt it was important that if we're going to be operating this facility, that we knew what we were doing. And as a result, we had no active opposition on the project. And we continue today with the same outreach program as far as having a speakers bureau, going out, educating the elected officials. They don't remain in office forever. And so we do have a cycle that we have to continually educate. And it's very, very important. And as I mentioned before, one of the keys to success of the project.
And a final question, actually this will lead into Jeff's presentation. So at the beginning, I imagine you had your list of potential contaminants that you were concerned about, and I know from the other presentations we've seen, they got their list of known contaminants. Have you had any additional contaminants that have been added to that list since, and how have you dealt with those?
We haven't had any added to the list so far. As I mentioned in the presentation, we test for over 400. They were developed mainly by the expert panel. Because we hadn't had regulations before, the expert panel advised the regulators, and between the regulators and the panel, they came up with the list and the detection limits, and we've abided by those and been able to fully meet our permit and been totally compliant.
All right, and so with that, thank you very much. Next up, we got Jeff Mosher, who's going to talk a little bit more about the science and research behind the technology that we're talking about, and set us up for some really good questions after that.
Thank you, David. So thank you, David, for the introduction and for the chance to be here. So I'm with a nonprofit called the Water, Environment, and Reuse Foundation. We're a relatively new organization. I'm going to tell you a little bit about the history, but what I'd like to say is that we're sort of the research arm that's looking into a lot of the questions that come up here. And it's useful for me to go after Mike because you got to see a project discussed. And what I'll be able to tell you is fill in some of the details on how we've been doing it as an industry. Both Hampton Roads Sanitation District and Orange County Water District are members of the Water, Environment, Reuse Foundation. Mike is on our board of directors. Hampton Roads Sanitation District, Charles Bott has been part of a number of the committees. So it's very collaborative when we look at these issues as a whole. So the other thing I just want to mention briefly is I did grow up in Norfolk, Virginia, and I went to William and Mary, but I spent a lot of time over the past 25 years in Washington, D.C., working on national regulations related to water. And the last 11 years I've been out in California working with folks like Mike Markus and other agencies on recycled water. And what's interesting about recycled water is that we've been doing recycled water for a number of years. We've been doing non-potable for irrigation issues, and that's fine. But now we're realizing the potential for potable reuse. So a lot of what I'm going to talk about is getting into that area and the promise of that. But first, just a little about WENRF. We were formed this year, but it was a merger of organizations that have been around for a couple decades. One of them was the Water Reuse Research Foundation, which focused on recycled water. And the other one you may have heard of more is the Water Environment Research Foundation. That's focused more on ambient water, stormwater, wastewater, discharge, that sort of thing. The reason why they formed is they want to have a bigger impact and work on these issues related to integrated water management, and recycled water is a big part of that. So really, when we step back and think about why we want to do these programs, you heard a little bit from Hampton Roads, but also from Orange County, is that we want to improve our water supply resiliency and reliability for a couple reasons. One is just a changing environment, not being dependent on one source of water. We want to be able to provide water for the community and environment, and we really want to move towards more a sustainable water management point of view. We want it to be reliable. Out west, we have droughts that we have to manage through, and a lot of these are going to be addressed through local water supplies. So it's going to be recycled water, storm water, things of that nature. So at WNRF, we're really looking at the full spectrum of water. So all these pieces fit together. We use this idea of it's all one water, all these things factor together, and we need to stop managing these as individual silos and start thinking about it in an integrated way. So just an example of this, David Sedlak, he's a professor at UC Berkeley. He wrote a book a couple years ago called Water 4.0 with the idea that, water 1.0 was the Romans bringing in water through aqueducts, 2.0 was doing wastewater treatment, 3.0 is recycled water, but now we really want to think about things like wastewater much differently. There's a lot of resources in there we can recover. One of them is water for other purposes. So we're doing a lot more in trying to think about how this is going to work on a community level. So indirect potable reuse is what Hampton Roads Sanitation District and Orange County District is doing. They're using the environment to take wastewater, treat it to a higher level, and put that water in a groundwater basin. You could also put it in a surface water reservoir like doing up in Upper Appoquan. And then there's a cycle here. So it's pulled back out, it goes back through water treatment, through wastewater treatment, advanced treatment, and back in the environment. The benefit of the environmental barriers can be great. They provide time, equalization. The groundwater barrier provides you a lot of additional treatment through natural filtration. So there's lots of reasons why you want to put the water back into an environmental buffer. So one of the things that was alluded to, David, was the idea of going to direct potable reuse where we eliminate the environmental buffer. So these types of things is provocative, but we've been so successful on indirect potable reuse, we have the ability to consider this. There's actually one plant in the United States in Big Spring, Texas, that's doing this. They take a wastewater effluent, run it through advanced treatment, and send it into a water treatment plant, into a distribution. They did it because they hit a wall. They literally ran out of water. In order to have a next water supply, they had to do this. What's nice about this concept, it's driving a lot of the research currently, and that's going to be a little bit what I'm going to talk about. One reason we're able to do this is that our highest science body in the land, the National Academy of Sciences, the National Research Council, they looked at the idea of taking wastewater and augmenting drinking water, and they endorsed it, that this could significantly increase the nation's total available water resources. When you have something like this gives us the ability to go out there and talk to communities about it. So in terms of implementing potable reuse, you heard some of the benefits from Mike. There's limitations on non-potable. This gives us the opportunity to have large increases in water supply. It improves reliability, and it's a sustainable supply. It's climate resilient, it's a local resource, and it provides a diversified water portfolio. So it seems to be stuck. No. Can you go forward? Okay, so this map, I don't expect to read all the agencies, but these are agencies in California, most of them in Southern California, that either have indirect potable reuse project or thinking about an indirect potable reuse project based on a lot of success we've had at Orange County Water District. So that's a large number, but there's also interest in Arizona, Texas, Florida, Colorado, New Mexico. So there's substantial issue growing for potable reuse, including the concept of direct potable. So I don't know if the battery went out, but maybe if you can keep advancing it. So the current potable reuse projects, there's a number in California, there's a number across U.S., including the Upper Occoquan in Virginia, and there's a couple internationally in Singapore and Australia. So when we look at the question of potable reuse, we find that there are key questions. And so one of them is, do we have the treatment technology to be able to do this? And we do, they're proven. But in order to evaluate them, we need criteria for pathogens and chemicals. And you heard the long list from Charles in terms of what they're looking at. Some of them are regulated, but there's many that are non-regulated we have to understand. The monitoring is going to tell us that the treatment is working like we think it's supposed to. If we find from monitoring during operations, if something goes wrong, we can turn around that water that's off-spec and not have it go into the ground or a distribution system. Source control, we want to keep chemicals out of the collection system. That would be the first step. Operations and operators, human error is a factor, and we have to make sure that we can address that. The response time, if we go to DPR, we're going to have less time, so we need to be able to respond to that off-spec water, and public acceptance. So at WNRF, we have a research program on polar reuse. We've had 34 projects since 2016. We've divided them up in different categories because at the end of the day, it's not just technology, but it's really understanding how to implement these projects. So we have utility topics, some of that's operations, and we have community topics, and some of that has to do with the public acceptance. So we try to research how to do these things well. So from a regulatory, utility, and community point of view, we want to cover all those bases. So just from a policy point of view, these projects are an intersection of these three factors: regulatory, outreach, and technical. They're not just technical projects. In California, we had an expert panel looking at polar reuse, well, specifically direct polar reuse, but the issues are similar. And what I found useful about what they were thinking about is the questions that they considered. So one is, what's this continuum of polar reuse, from environmental buffers all the way up to direct polar reuse? Are the treatment technologies available, and are they reliable? Do we have multiple barriers to address the water quality questions? Is there information on health effects associated with these chemicals and pathogens? What to do about off-spec water, the monitoring associated with that, and other scientific and technical issues. So one of my last slides is basically this question of acceptance, and every community grapples with this, but what we have found, even in communities where there is reluctance to that, through appropriate education and outreach, you can gain acceptance within the community to the point where it can be accepted, and that's been done in several places across the United States. So I do want to mention, Mike mentioned the expert panel at Orange County Water District. I had the privilege of being involved with that for 11 years. It was very successful. We're running one for Hampton Roads Sanitation District through the National Water Research Institute. And the folks that we get on there are people that can help advise on these tough questions related to treatment technologies, water quality. We have a microbiologist and a chemist on there. A hydrogeologist, we have a groundwater modeler. So the idea is that these people have the backgrounds to be able to address the questions that come up as part of their project and give them advice on how to move forward. And thank you again.
All right, thank you very much. I guess a follow-up question, because that was pretty broad-ranging. Thinking about the eastern groundwater area of Virginia, is there one or two big science and technical issues that you would consider to be key or paramount as our state and federal policymakers start to make decisions? So what are the unique things that we need to pay most attention here?
One thing I learned from the work at Orange County Water District is that's a very well-managed basin. So it's very engineered, there's a lot of water going in and out, and they have hydrogeologists and a model to be able to understand their basin very well. And so that informs them in terms of decisions, it informs the regulators in terms of how TDS levels are going to change. So the fact that you have a model, a robust model, is very important. The other thing, and Hampton Roads Sanitation District mentioned this, was the idea of being able to put water in there that doesn't cause other problems. I think we have the monitoring to determine the water quality going in, but one of the questions that's come up, and they've looked at it at Orange County Water District, is that water of a nature that it's going to mobilize metals or have other issues, create byproducts, that sort of thing. And so being able to understand that, they have monitoring wells nearby to where they inject it. So you have to have those measures of monitoring to be able to demonstrate the water quality that's going in and its impact on the groundwater basin.
And actually, that's a great segue to kind of a follow-up question, because somebody had earlier mentioned the fact that with the Occoquan Reservoir, you had the Occoquan Watershed Monitoring Lab, and of course, they've been doing monitoring and modeling since that project's inception. And so do you think that is a good model for what we're talking about in Hampton Roads? And if so, when should we get started on that?
So I think it's already started within the project. So they're doing the monitoring from the pilot. So that's the start to see what's coming in and then what's coming out. But Tom Grizzard, who's one of the expert panel members, managed that program for Upper Occoquan for decades. And so I assume that he'll probably have some advice on what that would look like. That one's a little bit different, and that's an independent authority. It was set up at the time that they got their permit. They didn't want the agency to do that. They wanted some separation, some independence. I think we've learned more from that, or since then, in terms of Mike's project. They do all that testing themselves. Some of it they send out to laboratories, but we have procedures. I don't think we need an independent authority per se, unless that's something the region wanted. But I think some sort of program with some sort of oversight would be easy to set up.
Okay, thank you very much. All right, next we have Peggy. Peggy, you want to come on up? All right, to get Peggy queued with her presentation, one of the questions that has come up throughout the afternoon is the potential benefit of this project freeing up nutrient waste load allocations. And so we've seen how important that is even within the General Assembly when we're talking about the Tranland project and how do you accommodate new industries coming in, from that to, how do you ensure that our MS4s are able to meet their Chesapeake Bay TMDL nutrient reductions in a cost-effective manner. So I know that there's some folks who have embraced that. There are some folks who say, hey, if you're able to make those waste load reductions, the purpose of the Clean Water Act was to, maximize the amount of pollutant load that you're reducing. And so it really is kind of a fundamental question about who should have control over the final disposition of those nutrient credits should the project go along. And so with that tee up, Peggy, the podium's yours.
Thank you. Thanks, everyone. Thanks for being here, holding with us in the middle of the afternoon, and thanks for my very esteemed co-members of the panel. This is a really exciting project. We all know that. In fact, every time I come in the context of listening to Ted and talking to others about it, I find myself with a little bit of a lift. It's not that often that you get such good news. So I wanted to show you a slide that you've already seen before. This came from Ted's materials, just to remind us what we're talking about. This shows, as I understand it, all of the facilities that HRSD has in the region. As Ted has told you, I think the current plan is to involve 7 of them in the injection process, and those are 2 on the Elizabeth River, 4 on the James, and 1 on the York. In other words, those basically centered on the river fronts rather than directly on the bay. Keep in mind, I don't have an overlay slide, but in this area, we have 6 Phase 1 MS4 localities and quite a few MS4 Phase 2 localities, sort of in the same context. So try to keep that map in your mind as we talk. Ted has told you in great detail about the major changes that SWIFT contemplates. Most of you know these terms, but I'll just go through them for convenience. These facilities, like all other significant dischargers, are required to and do operate under Clean Water Act required permits. Those permits, and in particular in Virginia, it's the Watershed General Permit with respect to nutrients, prescribe a maximum authorized discharge for these pollutants. That discharge, among other things, is consistent with in Virginia, the tributary cap that was originally set back in about 2005. It's also consistent with the caps that are reflected in the Chesapeake Bay TMDL. If SWIFT is successful, I hate to say if, because we really want it to be successful. If it is successful, it would permanently end virtually all of these discharges. I use the word permanently in quotes, partly because I'm quoting from HRSD materials, partly because, frankly, it is a question that we have. If it is successful, that waste load allocation, that maximum authorized discharge for each of these permits would be no longer needed by HRSD, and HRSD proposes to trade or sell that extra unused waste load allocation as credits under the Virginia Trading Program, likely to include as buyers some or all of the MS4s in the region. Is this lawful? It has been asked. I say yes. Some people say no, because they take a different view, I think, of the Clean Water Act. in any event, the devil's in the details, as always, for a final answer to the question. The legality of this kind of a transfer program ultimately does go back to the Clean Water Act, and I just cite to 301, which sets out the fundamental design of the permits. They have to include technology limitations, and in cases where technology is not enough, water quality-based controls. And trading has been recognized by many people, including EPA, for many years now, to be a tool that can assist in a cost-effective and potentially market-based way to get to the goal of water quality standards for the water bodies at issue. EPA has elaborated on what it considers to be the principles associated with trading in a variety of contexts, including its trading policy, which is now, I think, about 2 decades old, a trading toolkit, and in a variety of different ways and in specific contexts. Those materials emphasize some of the basic principles of trading. It has to control all pollutants that have a reasonable potential to cause exceedances of the relevant water quality standards. It can't cause localized pollution, and the trading has to be consistent with the assumptions and requirements of any applicable TMDL. Now, I'm going to skip over Virginia for just half a second. Because we do trading under several different umbrellas here in Virginia. What I've done here is gone to a part of the Chesapeake Bay TMDL document where trading in the Chesapeake Bay watershed is examined in some depth with quite a few principles that need to be addressed to make sure that a trading program is consistent with and will further the objects of the TMDL. I haven't listed them all here, but some of the ones that are most important in the Virginia context I've listed. And the first one is there has to be an appropriate state authority that authorizes, describes, enforces the trading program. And of course, we know Virginia has a longstanding program since about 2005 when policymakers and legislators recognized that trading can be a tool that does two very important things. One is to maintain the pollutant cap that in the case of Virginia is established for nutrients and sediment for each watershed or each tributary and for the bay, and also is designed to ensure that as a culture, as a commonwealth, we may have economic development. And that's, of course, an insight that has been built on in many years since then, including most recently in 2012, when the program was expanded to specifically permit MS4s to accept credits from credit generators and apply those credits to their own permits, giving them more time to put the practices on the ground that will ultimately achieve water quality standards. So Virginia is very familiar with this, a very complex set of regulatory documents which create the program, both in code, regulation, in permits, and the documents associated with the permits. For time, I'll skip down to both the safeguard portion and the use in nutrient impaired segments set of principles that are in Appendix X. Both of those, in different ways, emphasize an important part of a successful and, I believe, Clean Water Act compliant program, and that is that it must lead to a reduction in pollutants, ultimately to reach water quality standards. Can't just move the pollution around. It has to not create hotspots or impairments in local receiving water quality or any intermediate water quality. And so care is taken and must be taken to ensure that the program actually leads to water quality benefits. Assuming all of those things are met, then I think we have a successful Clean Water Act program, which could happen here if we do it right, which we have a good record of doing, so maybe we will. The question was asked of CBF, do you think there are water quality benefits associated with this kind of a trading program, and in particular with the idea that the waste load allocation unused could be as credits used by somebody else? And so you have to start off with a fundamental premise that how can it be a bad thing to get rid of all of these nutrients and sediment every year going forward when they would otherwise go to the bay? That's a hugely important benefit, assuming all things work out. And I put this graphic up again. This is from HRSD materials, but it emphasizes with respect to each of the three main bay TMDL pollutants, nitrogen, phosphorus, and sediment. This project is projected to eliminate upwards of 90% of the pollutants going forward annually. Those are very big numbers. What will that do? Well, you know, we all know what it would do if all of those pollutants were not to go into the Elizabeth, the York, and the James. Certainly, there would be significant water quality benefits to the habitat, to critters, and so forth. And I say that, it's obvious, but I want you to keep in mind, this is an opportunity that we're looking at for water quality benefits. If you separate out the SWIFT project as a whole, meaning the injection and the elimination of that nutrient flow, from simply the part of it that relates to the transfer of credits, what benefits do the transfer of credits themselves provide environmentally? Well, if there's a whole lot of credits floating around, it might deter people from coming up with some odd and kind of wacky BMPs that people have been talking about sometimes. Wacky is in the eye of the beholder, of course. But of course, realistically speaking, what we're not talking about is just eliminating the flow of nutrients and sediments. This graph, again, HRSD materials shows in a different form what Ted was talking about earlier. The bar in each case to the left, as I understand it, is the unused waste load allocation that would be releasable into credits. And the bar in each case on the right shows how much of that would be used, assuming we were to meet all of, or virtually all of, the stormwater MS4 related needs with those credits. Huge difference. So let's say it all goes to MS4. What else are we going to do with the rest of it? And of course, that opens up quite a big set of policy questions. There are also concerns. There are policy questions, and then there are concerns that arise in the context of those questions. One is, what actually happens to stormwater? Many of you know Virginia has spent a long time getting ready to, and finally in the last year, issuing this last 6 major MS4 Phase 1 permits for the Hampton Roads cities. Plenty of work had been going on, of course, but those permits actually would have, we think, moved that work forward, getting practices on the ground that would have benefits not just for the Bay, but for our local streams in the Hampton Roads area. If Hampton Roads now is planning to get all of its permit compliance from credits, what's going to happen to local water quality in streams? How are we going to keep what is just starting to happen going in a way that we get some permanent reductions? What will happen to regulators' appetite for continuing to work in this area? What about public dollars that might not go to BMPs that are for stormwater, but also have resiliency, flood control related benefits? What about green infrastructure? All of those initiatives are just getting off the ground. Will they be stalled now? Is that a wise thing to happen? If we have on the market a flood of credits from these 7 facilities, are we going to hear, and I think the answer is yes, we all know this, all kinds of proposals that might lead to damage to what has been in Virginia a fairly stringent, pretty well accountable system for trading? We can't trade outside a river basin, for example, but proposals to cause outside basin trading come up on a regular basis, and they might happen a lot more now that we see this trove of credits. So we need to be aware of that possibility and remember the water quality concerns that led to this, especially as in the same fashion that Ted talked about it earlier. I'm going to quickly, because I'm over time now, go to some recommendations I have at the end, quite a long list of them, but my point is this. it's an opportunity that we have. Assuming it works technically, we have a huge opportunity, and it's an opportunity we should address with water quality in mind. Can we retire some of those credits permanently? A proposal to do that, we are required to do that in the non-point source context. Shouldn't we carry over that model to this situation where we have this possibility? What about, anyway, just to move along, what about making sure in a variety of ways that HRSD credits are protected and not sold for a time period to enable us to make sure that the technology works? We don't sell any for a year. We hold on to a certain amount to take care of upsets and unanticipated discharges. I think Ted addressed some of those points in his presentation. Should we, and I would say we should, take this opportunity not just to retire credits, but also to focus again on the question of how in Virginia, in our regulatory system, we ensure the protection of local water quality. Lots of protections now exist in law, but keeping in mind this map, we're going to have not sort of linear transfers, credit source to credit user, upstream to downstream, but all kinds of potential credit transfers are going on in a complex way in this area. Big area, lots of complex possibilities. We're going to need to focus on our local water quality, and that will both protect the water quality. It will also protect the public's trust in our trading system. So that's all I'll say for now, but thank you very much.
Thank you very much, Peggy. And one of the things that I greatly value that we have in here in Virginia, and I've seen other states that don't have it, is that genuine collaboration among state, federal, but I also think equally, if not more importantly, our nonprofit sectors like the Chesapeake Bay Group. So, anyways, thank you very much for that overview. I do have a quick question because you did talk about local water quality. And so we've talked about trading, and we've talked about sediments and nutrients. One of the things, of course, that's being asked here with regard to the consent decree is to allow for this project to go forward to make it financially solvent and to go ahead and push back some of the efforts with regard to the sanitary sewer overflow. Is that something you feel comfortable with? Do you have concerns? Are there issues that need to be put out on the plate for that as well?
So the sanitary sewer issues that are now regulated by the consent decree are an important part of the method by which our local water quality is protected, particularly against human-sourced bacteria and viruses. The work's been going on, as Ted described, for some time. And that it's important work. When you have a proposal to slow some of that work down, together with the possibility of slowing actual work on stormwater BMPs down, the concern for local water quality is enhanced. I will say that the proposal, as I understand it, includes what appears to be a well-thought-out plan for identifying highly sensitive, high priority areas, waterways that are drinking sources, waterways that are used for recreation, waterways that are used for shellfish production. And in that sense, my understanding is HRSD plans to move forward with those projects, but other projects that are less sensitive, to put them at the end of the road. So certainly that has a practical aspect that would mitigate the harm of postponing most of the work. Just on a regulatory basis and as a matter of some interest, it is of concern that on several different ways we would lift the regulatory feet from the pedal on these long-term hard issues. How do we get it back on? So it would be important that whatever framework is developed in a modified consent decree format, that the schedule is clear, what needs to be done, when it needs to be done, and that it's done in the shortest time frame possible.
Thank you very much, Peggy. Now we move on to Russ Baxter. And so we have had multiple representatives from the General Assembly up here. However, we have, and you could stay down there, and he's our only representative from the executive branch, so he has the entire weight of the governor's office and every executive branch you can think of on his shoulders are riding on you today. I think he's breaking out in a sweat, yeah. But anyways, I appreciate you being here and taking some questions, so no pressure whatsoever. But I did want to build on, and you were warned of this question in advance, but I did want to build on the question that we asked Peggy, which is with regard to nutrient allocations. Where is Virginia in the process of that? Because I know, again, with the Tranland project and the James River, that kind of really came to bear, and so I know you're working in that direction, but could you give us a quick update about where that stands and what is the likely framework that Virginia will use to move forward?
Thank you, Delegate, and I accept the weight that has been placed on my shoulders. As an appointee of Governor McAuliffe, I have to use the words new Virginia economy in every presentation that I make.
You also have to say laser focus.
And laser focus, yes. I would just say that, there has been nearly $14 billion of investment in Virginia for economic development projects. And the good news of that is 95% of it has been for craft breweries. So, we're really making progress in this administration. But back to the topic at hand. This forum is actually very well timed. Yesterday, I submitted a report to the governor that he called for with his signing of Executive Order 52 last January. And that report is looking directly at the kinds of issues that are raised as we talk about nutrient allocations moving forward. We have, and the patron of the bill is even here today, if Brian is still here, back in 2005 session when the Watershed General Permit was conceived and the trading program began, that has been, I think, largely agreed amongst whoever you ask, a great success. But we have to look to the future. Economic growth is coming to Virginia. Economic growth hopefully will continue to come to Virginia. Population is going to increase. I don't think there's much doubt about that. And so we have to look very forward on how we're going to deal with nutrient allocations in the future. This project is what's so exciting, and I'm not a water quantity guy or drinking water guy. I've spent most of my career working on water quality issues, particularly Chesapeake Bay water quality issues. And this is tremendously exciting. We are, the greatest worry was bumping up against the nutrient cap, and then that's it. Either facilities would look at the Chesapeake Bay Basin in Virginia and say, well, we don't want to have to fool with getting nutrient credits and, we'll go somewhere else, or that there would be no possibility of expansion of existing facilities. I mean, there are potentially dire consequences if we didn't manage nutrient allocations properly. In the report that I submitted to the governor yesterday, and it should be on the Secretary of Natural Resources website today, it's been mailed out to the committee members, the stakeholder group that we worked with over the course. Several of them are here today. In fact, one sitting right next to me. Is to really look at that, at the future of these allocations, and to put in place a process by which we take a periodic evaluation of what those allocations are and what they need to be. We set the original allocations. It was really, the pie was divvied up in 2005, and it's not 2005 anymore. Things have changed. There are some, poster child facilities that don't discharge nutrients anymore and won't ever, that still hold nutrient allocations, and that, in my mind, doesn't make sense. I think over a period of time, and we're looking forward to 2020, 2030, sort of the life of what facilities do in terms of planning and financing upgrades and expansions of their wastewater treatment facilities, is having a regular process of periodic examination of what those allocations should be. Have there been significant changes in the service area? What technologies are in common use in the future that aren't today? And so all of those questions, in my mind, from a public policy point of view, given that nutrients in the Chesapeake Bay watershed are what I would say a valuable commodity and one that should not be wasted, we have to look at those things, I think, systematically, rigorously, on a regular basis, and make judgments as we move forward. I guess I'd dissuade the notion, and it was brought up by the student presentation that preceded us about this question of whether or not these allocations are a property right. I don't believe they are, and I don't believe that that's implied in the code, even though they are traded like property. It's kind of a funny situation. But they're really an artifact of a regulatory process. They are granted through a permit, and that permit can be changed. The state doesn't have to buy them back from a facility. I'm not suggesting that we're out to grab allocations from facilities. I think we had a pretty good handshake deal that was written into the code, and that is facilities would be granted the allocations that they needed, that they were going to be required to treat at a lower level and discharge less nutrients per liter, but they were going to be allowed to use the full design capacities of their facilities. And that was really the deal that was struck back in 2005, 2006, when we worked through these issues initially. But as I said, it's not 2005 anymore, and we've got to think creatively going forward about how we best use these allocations in the future. We're also, unfortunately, in a period of great uncertainty. As Rich Batiuk well knows, we're in the midst of the reevaluation of the Chesapeake Bay TMDL. We are hopefully coming to the end of a multi-year study of the chlorophyll standard for the James River. There's a new administration knocking at the White House door. And so what that will mean for the Bay TMDL, for Rich's job, for whatever, I don't know. And so I think there's, just a number of things that are challenging. 10 years ago, I was a much more inexperienced in the ways of the world, I guess. And I sort of thought, well, everything's going to work out. We will drive innovation by putting these caps on, and there's going to be stuff we never even thought of. Well, things maybe didn't happen that quickly, except Ted Hennepin came along, thank God, and didn't make me a liar. But I think, we're going to have to understand how to live in the world of a nutrient cap. We've never had to do that before. And that is going to drive innovation. It is going to drive projects like this and make them more economical, I think, probably for smaller facilities. HRSD has much greater resources than the average sewage treatment plant. It's a big firm, so to speak. And so I believe, change is coming. I believe we're on the cusp of new technologies that will allow us to adapt to those changes. And we'll just see what the future holds.
All right.
Thank you.
I got one question before I let you off the hook and put Rich on. A couple times today, it was suggested or alluded to that there are other states that actually charge for water withdrawals out of the groundwater as part of the permitting process. And so given that the benefits of the project, of course, don't just help the Hampton Roads ratepayers, but indeed help a lot of other folks, do you see any merit to that? Is it something that's worth exploring, or is that a place that we don't want to go as Virginians as a policy standpoint?
If anybody tweets this out, I'm going to kill you.
You better not say it.
No, I'm just joking. let me take the bureaucrats' approach to that. The JLARC just released a report on water use in Virginia, drinking water use, and the challenges of the Eastern Aquifer and many other subjects. And they broached that subject. One of the options that are in the JLARC report is the possibility of a withdrawal fee for groundwater. And I think that's obviously a legitimate topic of discussion. Whether it is from the, which side it's on, seems to me it ought to be on the user side. User fees are something that we're pretty well familiar with in a variety of contexts. So all I would say is that is something that has been brought to the legislature, Mr. Delegate, and it is something that is certainly worthy of discussion because, I'll cry poverty. The natural resource agencies, DEQ, we are less than 1% of the general fund budget and being asked right now to cut right now. And so we've got real challenges in our regulatory responsibilities and our ability to oversee activities as we properly should. And so streams of income, I frankly always find attractive. How that works out, I don't know.
Nicely pivoted, thank you. All right, so now we got our final speaker here, Rich Batiuk, who I've known also for a number of years. And I really have two questions. You can answer them in either way that you want to do it. The first one is, maybe you can tell us a little bit about the public input process that the federal government uses for the underground injection control permits and whether you think that is sufficient for a project of this size and complexity. The other question, of course, as was shown in some of our panels earlier, groundwater withdrawals in general are a state issue. But if you want to inject something in, that comes under the federal purview. And my understanding is it's a federal program unless Virginia would be interested in taking primacy for that. And so I guess the question is do you see any benefit to Virginia taking on that role? Either in the short term with respect to how the permit moves along and the input process, or even in the long term with respect to how we manage ongoing operations and maintenance costs for the facility. Take it away.
Thank you. Well, according to Twitter feed, EPA is still out there, so Ted, you still got to deal with this, buddy. Yeah, give it some time. First, on the public comment side is David referred to. EPA has got the lead for the injection side, not the surface water. So at a minimum, when we go out with any permit with that, it's a 30-day comment period. But obviously, for something as large and as encompassing as this, EPA is planning to work with Ted's team and others, the DEQ, Department of Health as well, to then say, what is the best approach to getting public comment to be sure people have an opportunity in a public hearing setting, in an opportunity to have Q's and A's, or on, I didn't realize it, Ted, but the TED Radio Hour, TED Talks. I'm looking forward to yours, Ted, when it comes up there. But seriously, so there will be an opportunity. EPA will sit down with our regional and state colleagues and figure out what is the best way to proceed from here. This is really a local state issue. It's not a regional issue. Although we have the permitting authority, we're going to design it to make sure that people's voices are heard. And you all have certainly, by this forum and others, have started that process. In terms of you all taking the lead on that, I'm not sure how long it takes to go through a designation. That's certainly the Commonwealth's question. I think, particularly in this, talking to my colleagues who handle this, who are both in my Philadelphia office and our Wheeling laboratory, they feel like myself, this is really a state, regional-driven set of issues. We are in a support role. Yes, we signed the permit. We need to be sure that the assurance is there, but this is really an issue that you all need to take hold of. It is your future, how you want to proceed from here. If there's a time that the Commonwealth wants to take that on, there's certainly a process that's involved in there. And I wanted to get at one of the questions about trading and local water quality. EPA's role is really to ensure in the TMDL context that there's reasonable assurance to the 18 million people across the watershed that everybody's going to do their fair share. They're equitable, not equal, but they're equitable share from the headwater states up in New York and West Virginia and Delaware to down here in the Commonwealth and that other Commonwealth to the north of us, who we've got some challenges to deal with. We also want to ensure that water quality standards in each and every one of what we call the Chesapeake Bay segments, each one of the rivers, et cetera, has got to be attained, and that is local water quality is done that. Other than that, EPA steps back and says, how you all want to trade, we've got confidence in Virginia's program. how you want to look at those credits, how you want to ensure that you can balance these things up. That is really, again, a local-state dialogue, particularly now with how far we are into the TMDL. The consent decree, under the advice of my new counsel, Chris Pomeroy. Chris offered his legal advice this morning. How far have we come, guys? You know, Chris, I appreciate your legal counsel on that. That one, I'm not sure of. You know, that is certainly something we need to continue to deal with. But first and foremost, and then at the end, it really has got to be a local, state, regional issue to be taken care of, worked out. Your EPA colleagues will ensure that where you take those reductions and how you distribute them does matter within the James, within New York, within the Chesapeake itself. The James itself, given its position, you guys are actually sending a lot more flow down to your North Carolina neighbors, but it still has an influence on the Bay itself. So we've got to take a look at those, but I think we've got strong science, we've got technical ability to make it happen, you've got a strong regulatory, legal framework. I think we have the confidence that's going to happen there as well.
So I'm going to end with one last question to you, which I hope will set up questions from the audience, which we'll have about 10 minutes, and then we'll head off and grab those oysters and beer. And I understand they got wine if you're into that too. One of the beauties of the Bay program is that it really looks to pull together all the different stakeholders, and then it's meant to integrate science and good policy together. And so I guess the question is, at the end of the day, once we've gone through this process, what does success look like? And how do we measure that?
I think Ted and I start walking into the lower Hampton Roads area and keep walking and walking until we can't see our white sneakers. I may drown sooner than him because I'm probably height impaired compared to him. But no, seriously, I think we have good measures out there. We understand what's happening here in terms of harmful algal blooms. You guys are bringing back oysters into systems that I thought would not see in my career. We understand what the issues out there are, so we have good measures. We have good monitoring out there. I also understand what you guys are facing, same thing of Annapolis. When we have 8 feet of water in downtown Annapolis and we can kayak up a third of the way up on Main Street, something's wrong in the system. So we understand measures as well as and within there as well. So I think we're well established to watch those measures. I think right now we've got a couple that in fact might look like they're going to conflict with each other. The local benefits, local reductions of flooding, et cetera. But I have confidence that this group in this room and others can figure out how do we balance that, how do we balance the financial pieces with what we're talking about here, which is truly precedent setting, at least for our area, not our Orange County colleagues who keep putting those extra maps on the map there. But I think we're in good shape to move forward.
Great. Thank you very much, Rich. All right, we open up the floor for questions right up here.
Good afternoon. It's certainly been gratifying and uplifting for me. This is great news. I'll make a remark, and I think directed toward Ms. Center and Mr. Baxter. Even if we were to achieve zero loading in the Chesapeake Bay, I think I'm fine. Isn't it a fact that without some kind of proactive efforts, such as shellfish aquaculture, it'll still take us a century to reach balance, a healthy balance in the bay?
I'll start off. I don't know about a century. I do know that there is a lag time built. You take actions on the land, and the systems, the natural systems, take some time to assimilate the effects of those actions. So yes, there will be a lag time. We're all hoping that it won't be so long as 100 years.
And I think Rich would agree that, we're seeing areas where that tipping point, I think we're really at the tipping point. You get a resurgence of underwater grasses and crab populations increase and water quality improves and dissolved oxygen is better. And we're starting to see that that is resisting the year-by-year fluctuations that we used to see. Even in times where there's some significant rainfall, SAV beds that didn't previously persist are now persisting. And so I really think we're on the right track. As Peggy says, there's a lag time. A lot of the flow that goes into the Chesapeake Bay isn't over land or from surface water, it's from groundwater. And so we have insulted the groundwater in many areas, and it's going to take a while for that to clean itself out. But I'm cautiously optimistic. I've been saying that since I got into this business in the 80s. Each year, well, I'm cautiously optimistic, but I'm naturally an optimist, I guess. But I do see genuine signs of resilience now, and I think that is being proven, not just my own, I'm a political appointee, and you must think I just say stuff to make the governor look good, but which I do sometimes. But in any case, I think we're seeing it from the scientific side of things as well.
Our scientists indicate.
There's a correlation between SAV increases and the increase in oysters in the bay.
No, there's certainly science behind that. Actually, I've seen photographs. If you go up in space and you look at the Susquehanna Flats, this huge 18,000 acre bed, you can actually see clear water on the lens coming out as the currents come through that system. You're right, oysters, little worms and clams on the bottom, underwater grasses, we can reduce everything, but we need to have, for those guts, those creeks, those embayments, we need to have those other filtration systems in there. So you can reduce on the land and reduce in the water, but you've also got to build them that natural filtering system. But the science also indicates the Chesapeake, she's resilient, but she also has a short-term memory, like some of us. I won't look at Russ, but there's not it's not a 10, 20-year lag once the nutrients get there. It is a 2 to 3 year lag within that particular system. It can bounce back from one of those 100, 200-year storms we've seen out there, but we've got to continue the direction that we're heading on.
Thank you. Other questions? Yes.
I had a question from the perspective of the Chesapeake Bay TMDL. Thank you. Appreciate it. Related to the SWIFT program and the Chesapeake Bay TMDL, y'all didn't really get into the timing discussion, but a little bit in just the 1995, starting the Orange County to getting it up and running in 2008. And we have this federal deadline of 2025. And I hadn't heard anybody mention that related to the SWIFT implementation.
Great question.
2025 is still in effect. The TMDL is out there. We've got a good, solid, essentially our understanding of what the James River ecosystem can withstand in terms of nitrogen, phosphorus, and sediment. That's in place. We've got new science coming in terms of understanding just how much algae should we be keeping in there for fish food and how much is too much in terms of harmful algal blooms. We need to build that science in, make adjustments working with our Commonwealth colleagues to then say, here's what you need to go. The other issues are how quickly can you get there and where those sources are going to come from. That's a part of what we would then turn to the Commonwealth and what we call their third phase or phase 3 watershed implementation plan. How does that fit in, and how does that fit in with the kind of stuff that you heard Ted and his team talking about as well? So yeah, it's not off the table. That deadline is still out there. It's still in federal promulgation. It's still been agreed to, as far as I understand, with 6 governors, a mayor, and my administrator, and we'll proceed with that. But I think we've got the framework set up. We know the parts, and this certainly will be factored into that discussion as well.
So that'll be considered in that 2017 consideration of trying to speed up that review so that we could actually meet the schedule for the
So I guess to be more-
2018 Phase 3 WIP?
more specific for Russ, is this likely to be integrated into the Phase 3 WIP?
We haven't started writing the WIP yet, but, we still have, I think we have to think comprehensively first. We've got agricultural issues and, other issues that we have to deal with. And there are local water quality issues as well as the larger bay issues that can flow from some of those other sources. And so, we see no reason to take our foot off the gas in terms of implementing practices to improve water quality. I really see the SWIFT and projects that will come after it, which I would anticipate as well, is, this is the room for growth. We're not going to, it's the population now is not going to be the population in 2030 and 2040 and 2050. The nature of businesses and other, factors of economic growth that come into the watershed. And so, we have to look for this under the long term. 2025 is the deadline for getting the practices in place to meet the TMDL allocations. But guess what? We got to stay at that 2025 level, well, potentially forever. And so that's where I get excited about these new projects, even if they are not part of our next iteration of our watershed implementation plan. They give me some comfort that we will be able to deal with growth and other issues as we move into the future.
Great. So we got time for one last question. Yes, sir, right in the middle.
I should have probably thought about this at lunch, but since the wastewater
is being treated so excellently by HRSD and Orange County using filtration and injection, it occurred to me that the same thing could be done with stormwater in Virginia Beach. The two systems are separate, and it seemed the idea of diverting the stormwater to be treated as well and injected would be a good thing, particularly since in the Lynn Haven River, there are 1,400 drains into the river that aren't being really treated. Also, Richmond has a mixed system, and I was curious if Mr. Baxter knew what plans existed in Richmond City for dealing with their stormwater and wastewater problems.
I happen to be a taxpayer of the city of Richmond. They are under a long-term consent decree from EPA to fix the combined sewer overflow problems. It is a hugely expensive and time-consuming project, but they have made progress, I think it's fair to say, in the last decade or so. I'm not an expert, frankly, on CSO. I don't know if there's anybody in the audience who is. Chris, help me out.
Representing the Richmond situation. They built massive pipes underground to capture the water, and it's actually treated now in a high-rate system with an expanded capacity of 30 additional MGD at the facility. So that's been about 20-year infrastructure improvement program to do that. It's ongoing in pieces, but the major elements have been completed.
And I would just add to that Richmond is engaged in a process of seeking to integrate its various water quality programs under an EPA program that is expected to and directed to prioritize the most impactful projects in a cost-effective way. It's been going on for several years and will go on for another 2 years, I think. The city officials in connection with that project specifically said, we're going to meet every permit requirement on time. We're just going to figure it out internal to those separate permit periods. That's relevant to me in part because of the integrated system that HRSD is proposing for SWIFT and its SSO work. Obviously, very different systems and very different timeframes involved, but it's interesting that both localities are proceeding to try to develop a cost-effective, modern method.
Folks, we are so thankful to have such a great panel here with us today. Let's go ahead and give them a big round of applause.